Hi, it's time for another math easy solution. Now, turn discuss further into parametric equations and curves and look at example 12 of the example series, which I haven't done in a while. We'll jump into it and go over line segments, which is, I find, a very important and useful example to go over. And that's this example. It states, show that the following parametric equations describe the line segment that joins the points P1 to P2, where the coordinates P1 are x1, y1, P2 is x2, y2, and we have these, or this parametric equation, or this set of parametric equations, x equals x1 plus x2 minus x1 times t, and y equals to y1 plus y2 minus y1 times t, where t is between 0 and 1. Then part B just says find an example where your line segment is from -2, 7 to 3, -1. So to prove this, or to show that we could write a line segment in the form of parametric equations, and that's the gist of it, what I want to show. For example, let's say we had x2 is greater than x1 and y2 is greater than y1. So for example, if we had a line like this is xy coordinates, and let's say we had just a random line like this, where this is at x1, this is at x2, and then what we want to show is, well, this is at y1 all the way across, here is at y2. Yeah, just draw that a bit better, like that, and this like that. Yeah, so then this point is P2, coordinates are x2, y2, and this one here is P1, like that. And let's write this down, x2, y2, and this one is x1, y1. So we want to show that we can write these parametric equations in for this line segment. And I'll just write this as A. So we want something like that. And to do that, we'll notice that this x and y are both linear equations. There's no t squared or square root. That's just a function of t like that. So what I'll write is, well, x equals to x1 plus x2 minus x1 t, and we have y equals to y1 plus y2 minus y1 t. These are again both linear equations. In other words, these are both describing a line, but on a x and t, and this is a y and t axis. Both linear equations, like that. So they're both linear equations, so that means, well, we just look at the interval from 0 to t. So that means, yes, this means that for, so I'll write for t is greater than 0 and less than 1, like this. Yeah, this corresponds to the same thing as writing, well, x of 0 to x of 1, like that. Yeah, I'll just fix that up. So x of t equals to 0 and 2x of t equals to 1. So this means that this t right here is, so t is within, or corresponds to within this range, like this. Within this range. Yeah, so if we have, let's say t is 0.5, that has to be somewhere in between these two, because it's a linear equation. It has to go there directly to it. There's no up and downs, etc. So what we have to do is, well, let's look at t equals to 0. So if x2 is greater than x1, then that means that, well, x of 0 must be less than x of 1, like that. But in this, in general, doesn't have to be. This is just a general. This is a specific example, but it could work for anything else. So we have, let's say at t equals to 0, what we have is x is equal to, well, if we look at the equation, yeah, look at it above here, we have x1, and then we have, this is 0, that just vanishes. So x2 minus x1 times 0 is a 0, and then what we also have is at y is going to be, well, this is 0, that vanishes, so we have y1, like that. So we have this over here. So this combines into, well, our point P1, which has coordinates x1, y1, like that. And then likewise, what we have here at t is equal to 1, we have x is equal to x1. So x1 right here, and then we have, this is 1, so that's just, yeah, we could just remove that. So this is just x2 minus x1 like that. This is times by 1. Then this is just adding these all together. This negative x1 and this x1 cancel. So we're left with x2 like that. And likewise for y, we have y is equal to y1. It's the same exact equation, but just remove x and y's. So we have y2 minus y1 times 1. The y1's cancel. We're left with y2. And this corresponds to the point P2, where we have x2 coordinates and y2 like that. Yeah, now what I've done is I've just moved this down further so that I forgot to include in this part here. So that for for t is between 0 and 1, this not only corresponds to t being within these values, x of 0 to x of 1, but as well as from y, because remember this is a linear equation as well, so they're both linear equations, so we have to move within, we can't just jump a point or go up and down, so this is also corresponds to y of 0 to y of 1 like that. And I just draw that a bit better. So this t has to correspond to y values that are between these two like that. And now that we've gotten both of these values, y0, y1, as well as x0, x1, which are these right here, x1, y1, and then x2, y2, that means that for t is less than 1 and greater than 0, this corresponds within the range, or yeah, so within x1 to x2, and also, yeah, that's right, and here, and within y1 to y2, exactly like that. Yeah, so if the value is 0.5, it's going to be a value between y1 and y2 and x1 and x2. So now the next step to do is, well, let's combine the equations by removing this t value. So we can do that. So next is remove t. And to do that, well, first thing we'll do is write our equation. So x equals to x1 plus x2 minus x1 times by t. Let's write this a bit neater. x1 times by t, and then we have y is equal to y1 plus y2 minus y1 times by t like that. And then we can remove the t by, well, they're both the exact same kinds of equations, so we can first subtract this x1, so we put a subtraction, and then we could divide that all together by this right here, so we do a division like that, so we can remove everything, get a t, so we have x minus x1, and divide x2 minus x1 like that, and this equals to t. And then the t, that's the same exact thing we could do here. We just or subtract here, divide here, and then what we're left with is, well, we're just left with t, which is the same thing here, so it's sharing a t value, so we have y minus y1 over y2 minus y1 like that. So there's what we have, and then we can equate these together, and then we can remove the t. So then we have, and I'll move the y in front, so y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1 like that, and we can move this over so we can more clearly show that this is in fact an equation of a line. So we have here y minus y1 is equal to, move this over, we have y2 minus y1, and then this is divided by x2 minus x1. Let's move this to the right. So we have then multiplied by x minus x1. So this is in fact a linear equation, or an equation of a line. You could see that by, well, at this point right here, this is, well, this is the same thing as writing delta y over delta x, and this is from the two endpoints. This is all the way from x1, y1 all the way to x2, y2. In other words, this is rise, or an arrow, so rise over run, and again, this is corresponds to the slope of a line. And this is from the points x1, y1 to y2 and x2. And I'll show you more clearly like that. So this is basically an equation of a line, and this is in fact a line from P1, which is x1, y1, to, and this is from up to x2, y2. And I'll show you more clearly this is, well, basically I'll zoom in a bit. So at x equals to x1, notice what happens when we could just plug this inside. This just vanishes. This x1 minus x1 is 0. So what we're left with is y minus y1 equals to 0. Move this y on the other side, we have y equals to y1. So there's our values like that. So there's our y1, there's our x1, and this corresponds to p1, x1, x1, and y1. Like that. That's just, well, over here. Like that. And likewise, at x equals to x2, what we have is y minus y1 is equal to, that's x2. Those cancel with this. So we're left with, well, y2 minus y1. I'll just write this down for completeness sake. x2 minus x1. Now we have x2 minus x1. This all cancels like that. We're just left with we're left with y minus y1 is equal to y2 minus y1. These just cancel, and we're left with y2. So we're left with y equals to y2 like that. So then these correspond to the point P2, x2, y2 like that, which is again the exact same thing here. So thus we've proven that we can write the parametric equations as in the form of a y equals to f of x like this. Well, if you just move this over, that's just a constant. So we have a form of y equals to f of x. I just want to, like that, as a function of it. And it's a line from P1, x1, y1 to P2, x2, y2. And that the t values are both correspond within x1 and x2 and within y1 to y2. So we've just proven that it is in fact a line segment. So that is our overall proof. And you can see this visually by, well, first of all, we know that if we were drawing this like this, we know that if this is the x and this is a t graph, and let's say we go from x1 all the way to x2 like this, or these values, let's move this like that. Yeah, just write it like this. So let's say we have it from x1 to x2, and then we're going from 0 to 1 for t. So 0 is going to be, well, 0, and then let's say we go up to 1 here. So that means at this point is over here. And then it moves all the way to where t is 1, so we have x2 is here. So this is just a straight line like that. And this line is, well, that's just our x equals to x1 plus x2 minus x1 t. So that's just an equation of a line on the x and t axis like that. And now if we were to align this accordingly, let's just say we had something that looks like this. This is x and this is the y curve. But first let's draw our y and t graph. Like that, this is y, that's t. And exactly the same thing we have at, let's say we have y1 here, and we have y2 here. And then at t0 is here, let's say we have 1 here, and they're both standard lines, and this is from at this point 0 and y1 all the way to y2 and 1, or 1 and y2, like that. So it's just a straight line across, draw a better line, and this is at y is equal to y1 plus y2 minus y1 times by t. So now what we could do is, like I've done before, well, let's just align this down now. We could align this visually as well to show you what it means. So x1 goes all the way here. Draw this a bit better. x1 goes all the way here, x1. And then y1 goes all the way across, like that. So yeah, y1 is over here. And likewise, for y2 goes all the way across here. So we have a point here. That's our x1, y1, and then this is all the way across there, just a bit high. So here I just quickly fix that up. This is our y2. Let's put that 1 there. So now we have this. This is at, well, this corresponds to this point. Let's just move this x2 down. So as you can see visually how it looks like, how the parametric equations can form this right here, and we know that it's a line segment from P1 to P2, and there is our line across, directly across it, where this is our y equals to f of x. Form like that, and that could be rearranged with this right here. Just move the y on the other side. So that is pretty cool. And this is at t equals to 1. This is at t equals to 0. So what that means is we can write these parametric equations, so like this one right here and this one right here, and here's box them in. So we could use these, combine them, and then we get a straight simple line segment, which is, as it seems pretty basic, but this comes in very handy in later videos. That's why this video on this one, just to show that we could just quickly write the parametric equations to draw a line pretty much anywhere we want. So if you were to graph stuff, you could draw pretty amazing shapes, which I'll try to get to in a later video, which is quite amazing. So in this one states, part B, find parametric equations to represent the line segment from -2, 7 to 3, -1. And that's quite standard. We go B. So this is at, basically, let's write that again. This is at -2, 7 to 3, -1. So what we have is, this is our x1 is -2. This is our y1. This is our x2, and this is our y2. So what this means is, our parametric equations are x equals to x1, which is -2, plus, now we have x2, which is 3, minus x1, which is, well, -2, like that, times it by t. This negative, that just becomes, add them together, that's a 5, so 3 minus -2 is plus 2, so that's 5. So -2 plus 5t, like that. And y here is equal to, this is going to be now the same thing, y1, which is 7, plus y2 minus y1. So we have -1 minus just minus 7 times by t. This adds up to -8. So this equals 7 minus 8t, like that. So there's our equations, and also we have t's between 0 and 1. So I'll just combine this all. So we have x equals to -2 plus 5t, and we have y is equal to 7 minus 8t, and where this whole thing is between 0, where t is between 0 and 1. So this is actually quite amazing, which I'll show in later videos, so stay tuned for that. So basically we could write any line segment anywhere on a y-x axis, and that is, just using these parametric equations, which is quite fascinating. So if you were to graph this one, let's just see how this looks, where this one is. This is at -2 and 7. So we have 1, 2, -2, and then all the way to 7. So that's this point there, all the way to 3 and -1. So we have 1, 2, 3, -1, like that. This is 7. So the line is like this. So it's quite amazing. Then you could quickly draw a bunch. You could draw a triangle if you want, etc. Just from parametric equation. You could write your name, etc. Other cool stuff, which I'll show in some graphing videos on these parametric equations, like I've done before. Anyways, that's all for today. Put a line there, like that. Yeah, so that's the curve. Let's write this quickly. This is 3 and -1. And this is -2 and 7. So anyways, that's all for today. I hope you learned from this quite extensive video on this seemingly simple concept of just writing line segments using parametric equations, but this has very powerful implications for future videos and future just applications in the real world. Anyways, that's all for today. If you learned, like always, you can download these exact notes in the video description below. Thanks for watching, and stay tuned for another Math Easy solution.